Welcome back. This is our last tutorial session for exam 1. Today I'm going to demonstrate the superposition technique. Here's our circuit. Let's first explain the basic idea of superposition. Suppose in a given circuit we have n independent sources. And suppose we want to calculate the value of some parameter, say y, which could be either a current or a voltage. Now, we drive the circuit with one of these n independent sources. In other words, apply only one source and deactivate all the remaining n-1 sources. Of course, when you do that, you are creating a new circuit. Now, for this new circuit, calculate the desired parameter, which is y. After that, drive the circuit with another independent source and again deactivate all the remaining sources. As before, you will have a new circuit, so calculate the parameter y again. Keep doing this until you have used all the independent sources. And finally, add all the results you have obtained for the parameter y to get the final answer. Now let's explain the previous steps graphically using the given circuit. Suppose we want to calculate the value of the current I passing through the 4 ohm resistor. Notice that the circuit has 3 independent sources, so we will drive the circuit with one source at a time. First, we will drive the circuit with the 7-volt source. The other two sources are deactivated. The 0.1 amp current source is deactivated by removing it or opening the circuit. The 3-volt voltage source is deactivated by replacing it with a wire. Notice that the current through the 4 ohm resistor is labeled as I1 now because the circuit has changed. Next, we will drive the circuit with the current source and deactivate the other two voltage sources by replacing them with a wire, as you can see. The current through the 4 ohm resistor is now labeled as I2, again because this is now a new circuit. So we can use now whatever techniques we've learned in chapters 2 through 4 to find this current I2. And finally, we drive the circuit with a 3-volt source and deactivate the other two sources. The current through the 4 ohm resistor is now labeled as I3, and again we can calculate I3 using any technique we want. Now, the original current I basically equals to the sum of the three currents I1, I2, and I3. Okay, let's now apply superposition to solve for the current in our circuit. First, we drive the circuit with a 7-volt voltage source and deactivate the other two sources. We have labeled the current through the 4 ohm resistor as I1 as shown. Now notice that since the current source is removed, no current passes through the 5 ohm resistor. Notice also that since the 3-volt voltage source is replaced by a wire, the 2 ohms resistor is shorted out. So let's clean up the circuit and continue. The circuit looks simple enough. Now we can use either KVL or Ohm's law to write the following equation. We have 7 is equal to I1 times 4 plus 8 plus 6, or I1 equals to 7 over 18, or 0.389 amps. Now let's drive the circuit with a 0.1 amp current source only and deactivate the other two sources. We have labeled the current through the 4 ohm resistor by I2. Again, the 2 ohm resistors shorted out. Let's clean up the circuit. Now we have the following circuit, and I have added the current Ix to help in writing the equations. Now let's write a KCL equation at this node. We have the 0.1 amp is entering, I2 is entering the node, and Ix is leaving. So the equation becomes Ix is equal to I2 plus 0.1. Now let's write a KVL equation for the outer loop, and this gives the following. We have the 8 and 4 ohms are in series, so we have 4 plus 8 times I2 plus 6 times Ix is equal to 0. Now these are two equations and two unknowns, and we can solve for I2 to get minus 0.034 amps. And finally, we drive the circuit with a 3-volt voltage source only. The current in the 4 ohm resistor is labeled as I3. Notice that no current goes into the 5 ohm resistor. Adding the resistors in series and removing the 5 ohm resistor, we get the following simple circuit. So this is our 2 ohms, and this is the equivalent resistance for the series resistors. And now we can easily find I3 from Ohm's law, and I3 is equal to negative 0.167 amps. Now I want you to think about why is I3 negative. I'm sure you'll figure it out. Just think about it for a little bit. Okay, so we're almost done. Now we are ready to calculate the value of the current I0 of the original circuit, and it's given by the sum of I1, I2, and I3, or 0.188 amps. And this is the end of this example and this tutorial session for exam 1. Hope you've enjoyed the tutorials. Good luck, and I'll see you in the next coming tutorials.